When Kelly is about to jump out of the airplane, she has potential energy, and when she jumps out, it turns into kinetic energy, which is the acceleration of gravity at which she's pushing on the air particles, exchanging her energy into the particles. For every applied force, there is an equal and opposite force. The two forces always act on the same object. When you are jumping out of an airplane, you are pushing on the air molecules, and the air molecules are pushing back on you.
Newton's second law states that acceleration is dependent on two variables, the net force acting upon it and the mass of the object. If the net force acting on the object increases, then this causes acceleration to also increase. In a case where the mass increases, then the acceleration will therefore decrease. When a skydiver is free falling through the air, the speed is accelerating downwards. For example, there are two skydivers, Kelly and Vic. Since Kelly's weight is less than Vic, she will accelerate faster. As the speed increases, the net force, which is the amount of air resistance, increases. Kelly acts as the projectile when traveling through the air. The point where the force of air resistance is balanced with the force of gravity, then the skydiver will no longer accelerate and reaches terminal velocity.
Newton's first law of motion states that an object at rest remains at rest unless acted upon by an unbalanced force, which is also known as inertia. Without this law, skydiving could never exist. If gravity were not acting upon the skydiver, like Kelly and Vic, they would continue falling in the direction of their initial fall. Since there are no surfaces in the air, there is also no friction. If there were no air resistance, the skydivers would continue to accelerate at 9.8 meters per second until they hit the ground.
For what?